Hello my dear students, welcome back to online classes. In my previous video, we have solved the exercises problem up to class 4. Today, we will discuss more exercises problem. See the first problem. This is the 5's one. Simplify a plus b by 2 whole square minus a minus b by 2 whole square. We have to simplify the first one. Okay. This is the solution. 5 number. 5's 1. A plus b by 2 whole square minus a minus b by 2 whole square. Okay. To simplify it, we know an identities for a square minus b square. Just to remind you, we know that a square minus b square equals to a plus b into a minus b. I told you to memorize these identities. So we will apply that identities to simplify this one. So you can consider the first one as a, then this is a square, and you can consider the second one as b. So a square minus b square. So it will be a plus b into a minus b. That means a plus b by 2, this is our a, plus b into a minus b. So a plus b by 2, this is the first one, minus second one. Understood? See, a square minus b square means first plus second into first minus second. We have used the same thing. A square minus b square equals to first plus second, see, into first minus second. Now take LCM for the first part. So it will be 2. Then if we divide 2 and 2, then it will be 1. And 1 into a plus b means a plus b itself. So a plus b plus again a minus b. So this is the simplified part of first part. Next again the LCM of second part 2. Same thing, a plus b minus there will be a minus b. So if we remove the bracket, then it will be minus a minus plus b. Okay. Now if we simplify the numerator, then here b will be cancelled out, since these two terms are of opposite sign, and here a will be cancelled out. Okay. So in numerator there will be 2a by 2. Why? Here a and a, these two a left. So a plus a equals to 2a into, for second, b plus b means 2b by 2. Now 2 cancel out. So ultimately a into b. This is also a standard result. Okay, you can memorize the question and answer also. Understood? Next. Okay, pause the video and note down the solution. Next, 6 number problem. Using the expansion a plus b whole square, evaluate 63 whole square. Okay, we have to compute the value of 63 whole square by using the identities for a plus b whole square. Okay, 63, to compute 63 whole square, you can use the as usual method. 63 whole square means 63 into 63. Okay, but we will not use that process here. Why? Since according to the question, you have to use the expansion a plus b whole square. Okay, so we will break this number 63 into 2 parts, so that verbally we can compute the square. Okay, whatever we need, easily we can compute. So to compute 63 whole square, we will break 63 by into 2 parts. One part is 60 and another part is 3. See, then 60 plus 3 itself 63, so whole square. Now we can use the expansion a plus b whole square. So what was the expansion for a plus b whole square? Try to remind it that a plus b whole square equals to a square plus 2ab plus b square. So apply this one. So it will be 60 square plus 2 into 5. A means here 60, b means 3 plus 3 square. Okay, 60 square means, first consider the 6 square. 6 square means 36, and for this 0 you consider 2 times 0 plus multiply these two. 3 to the 6, 6 is a 36, that means, and 1 0, 360, and 3 3 is a 9. Now add all these 3, then you will get the answer. So it will be 9 6 9. Okay, if we add the unit place, then 0 9 9, very good, and 6 and plus 0, it will be 6, and next 6 9, and 3 9 6 9. This is the answer. Okay, this complete the solution. Next, this one done. Next, you have to compute the square of 10.4. Okay, so again we have to break this number 10.4 into two parts, so that we can easily use the previous concept. Okay, this is third number problem, 6.3. Okay, to compute 10.4 whole square, we break the number 10.4 into two parts. One part is 10 and another part is 0.4. Okay, whole square. Again apply a plus b whole square, that means these identities, that means 10 square a square plus 2ab, a means here 10 and b means our 0.4. Okay, plus b square means 0.4 square. Next, 10 square means 100, you know, plus 2 into 10. Okay, 10 into 4 means it will be 4, and 4 and 2 8. Okay, plus 0.4 square means 0.16. So it will be, if we add the integer part, then it is 108 plus 0.16. This is nothing but 108.16. This complete the solution. Did you get it? Okay. Next, go to the next problem. Okay, next 7 number problem. Actually the 6, this is the same as 6 number problem. In 6 number problem we have to express the number into the form of a plus b, and for 7 number problem, read the question, this one. Okay, 7. Using the expansion a minus b whole square, evaluate 47 whole square. Okay, that means we have to break this 47 into two parts, so that the difference is 47. Okay, here we have to use the expansion for a minus b whole square. Okay, I am solving the first one. See, this is 7 number, 7 1. Here 47 square. So we can write 47 as 50 minus 3. Understood? So this is our a minus b. So now apply the rule of expansion or identities for a minus b whole square. What are the identities for a minus b whole square? It is a square minus 2ab plus b square. So apply these identities. So it will be 50 square minus 2 into 50 into 3 plus 3 square. Now simplify. 50 square means what? 50 square means 5 square, 5 square, and for 0, 5 square 25, and for this 0 we will consider 2 times 0, minus 3 to the 6, 6 into 5, 30, and one more 0, plus 9. Now add this will be 2509 if we consider this one and this one, minus 300. Okay, so we subtract this, then 9 0 2 2. This complete the solution. Understood? Next, third number problem. Pause the video and note down each and every solution. 7.3. Guess for problem number 3. Then how can we break 99.7 whole square into two parts so that we can use the expansion of a minus b whole square? Okay, 7.3 number problem. Here 99.7 square. So it will be better if we use here 100 minus 0.3. See, 100 minus 0.3 means 99.7 itself. Okay. Now break into two parts. We have break it into we have broken into two parts. Now use the identities for a minus b whole square. So it will be 100 square minus 2ab, that means 2 into 100 into b means here 0.3 plus 0.3 square. Okay, because 100 square means for 1 square 1, and for this double 0 we will consider 4 times 0 minus. If you multiply it by 100, then it will be 30 into, ultimately it will come 60. Okay, plus now if you simplify this, then you will get the answer. To simplify this one, so the first is, if you consider the first and last, then this is 0.09 minus 60. You will get 9940.09. Yeah, this. This complete the solution. Next, see the problem number 8. Use the formula a minus b into a plus b equals to a square minus b square. Find the value of the first one. It's 1. 97 into 103. We have to calculate the value of 97 into 103 by using the identities a minus b into a plus b equals to a square minus b square. So product part is there. So we have to make into the form of a minus b into a plus b so that we can use these identities. So if we try to make into that form, then 97 can be written as 100 minus 3, and in the place of 103 it can be written as 100 plus 3. So now see, 100 minus 3 into 100 plus 3. 100 minus 3 is 97 into 100 plus 3. So it become into the form a minus b into a plus b. A minus b into a plus b. Here a means 100 and b means 3. So we can use what? The answer is a square minus b square. So a means 100 square minus b square means 3 square. So 100 square means 1 square means 1, and for double 0 we will consider 4 times 0. Right? Minus 3 square means 9. So it will become what? 9991. Is it? One more 9 will be there. 1, 2, 3, 4, 5. 4 digits. Yeah, it's correct. Clear? Next, third number problem. Guess that how to break 50.7 into 49.3 into the form of a minus b into a plus b. So here 50.7 is there into 49.3. So 50.7 is can be written as 50 plus 0.7, and this can be written as 50 minus 0.7. 50 minus 0.7 means 49.7 itself. Okay, now we have converted into a plus b into a minus bc, so the value will be a square minus b square. So 50 square minus 0.7 square equals to 50 square means 5 square 25, and for 10 we will consider 2 times minus 0.49. So it will be 2, 4, 9.51, I think. Yeah, this is the correct. This complete the solution. Next, problem number 9. What we must be added to the following to make it perfect square? The question is what we must be added with this given so that we can make it to perfect square. Okay, I am solving the first one. See, hope you will be understand. Okay, the first one is given 9a square plus 16b square. So it is nothing but 3a whole square plus 4b square. So if you consider the first one as a and second one as b, so we have to add to make it perfect square either plus 2ab or minus 2ab. Okay, if we add here, see, okay, I am writing in different way. Okay, 3a. Okay, so if we add to it, so therefore we have to add 2 into 3a into 4b, then 3a square plus 4b square plus this term with this term 4b equals to 3a plus 4b whole square. See, only a square plus b square was there, so we need here 2ab, that's why we have to add 2ab. This completes the first solution. For the second one, see, it is given that 25a square plus 40ab. So try to convert it. So this is 5a whole square is given plus ab term is there, so it is impossible to convert it into a square, only the 40ab. So we will make it by 2ab. So 2 into a already we get 5a So rest part will be b. So 5 to the 10 into a gone. 10 into a. So left is 4 left and b. 4b. Okay. So we have to add. See, this 2 into 5 into 4b means 40ab and 5a square. So in this term we have a square plus 2ab. So we need b square, that means 4b square. So we have to add this term, understood? So we have to add 4b square whole square, that means 16b square, and 16b square. Therefore 25, okay, therefore 5a square plus 2 into 5a into 4b, and after add of this term we can write 5a plus 4b whole square. Understood? This complete the solution. Okay, next 10 number problem. 10 number problem is given that if x plus 1 by x equals to 5, find x square plus 1 by x square and x to the power 4 plus 1 by x to the power 4. So first you have to identify then what is given here. They have given that I am solving a 10 number solution. Times 1. They have given that x plus 1 by x equals to 5, and you have to calculate the value of x square plus 1 by x square. So you can solve this problem into different way. Understood? So I am solving the first process. After that I will discuss about the second process. So to solve the first process, we can square both sides of the given. So by squaring both sides, we get, so if you consider left square in left hand side, then this square equals to 5 square. So now expand the left hand side. It is a plus b whole square. A plus b whole square means what? A square plus 2ab plus b square. Okay, we will use that. Then x square, that means a square plus 2ab, that means this, plus b square means 1 by x square equals to 25. Okay, here x cancel out. So we are going to find out the value of x square plus 1 by x square. So we consider this term and this term in a group. Then x square plus 1 by x square. So these two terms gone. Only left term is here 2. 2 into 1 2. So take this term 2 into right hand side. So if we take this term right hand side, then it is plus here. So it will be minus 2. So implies that x square plus 1 by x square equals to 25. 5 minus 2 means 23. This completes the first solution. Okay, to get the second value, second one, you have to square again. If we square both sides of this, give this result, then you will get the answer. Okay, this is the first answer. To solve the second one, but we have x square plus 1 by x square, what we have? 23 equals to 23. Now squaring both sides, then x square plus 1 by x square whole square equals to 23 square. Okay, so again apply a plus b whole square, that is a square plus 2a plus b square. So the first term will be x to the power 4 x square and then x square, then it will be x to the power 4 plus 2ab, that means 2 into x square into 1 by x square plus 1 by x square x to the power 4, 1 by x square again whole square. So it will become 1 by x to the power 4, and 23 square means what? 23 into 23 multiply 3 3 are 9, 3 to the 6 plus 6 4 9 2 529. So 529. Next, here we are going to find out x to the 4 plus 1 by x to the 4. So make this group by x to the 4 and 1 by x to the 4. Here x square will cancel out. So 2 is there, only 2 plus 2 is there. So we consider this term. If we consider this term into right hand side, then it will be 529 minus 2. So implies that x to the power 4 plus 1 by x to the power 4 equals to 529 or 527. This completes the solution. This is the second answer and this is the first answer. This is one way. Another one more way is there. Okay, this is better for you. Next, 11 number problem. 11 number, if x minus 1 by x equals to 3, find x square plus 1 by x square, and second one x to the power 4 plus 1 by x to the power 4. 10 number problem and 11 number problem, basically same process, same to same. Okay, so you can solve by yourself. Just in the place of plus it will be minus. Okay, and squaring both sides and the same process. Understood? Okay, I am solving. Leave it. Okay, this is 11 number. For 11 number, it is given that x minus 1 by x equals to 3. So if we use the previous one, use the method of previous one, then we have to square both sides. Then squaring both sides, what? Left hand side will be x minus 1 by x whole square equals to 3 square means 9. Now expand the left hand side into the x minus 1 by x whole square, that is a minus b whole square. That means a square minus 2ab plus b square equals to 9. Implies that we need here x cancel out. We are going to find out x square plus 1 by x square. So x square, this is 1 by x square. So x square plus 1 by x square, keep it in left hand side and consider all the terms in the right hand side. So this is minus 2. So if we consider this term in other side, then it will be plus 2. Okay. So we have x square plus 1 by x square equals to 9 plus 2, 11. This complete the first answer. And to get the second answer, we have to consider again squaring both sides of this. So right, for 2 number problem, we have x square plus 1 by x square equals to 11. Just we copied this part. Again squaring both sides. Then x square plus 1 by x square whole square equals to 11 square by squaring both sides. So it will be x square whole square plus 2ab plus b square equals to 11 square means 121. Here again x square cancel out. So x square again square means it will be x to the power 4 plus 2 plus 1 by x to the power 4 equals to 121. So we have to find out x to the power 4 plus 1 by x to the power 4. So keep these terms in left hand side and consider all the terms in another side. Then 121 plus minus 2. That means 119. This complete the second solution. Understood? Okay. Pause the video and note down. In 30 number problem, it is given that 2p plus, if 2p plus 5q equals to 16 and pq equals to 6, then find 4p square plus 25q square. Okay, so easily we can solve this problem. Solution given here, 2p plus 5q equals to 16, and we have to find out now 4p square plus 25q square. So to solve it, we have to use the identities for a square plus b square. Okay, so I am telling you to remind the identities for a square plus b square. A square plus b square equals to, two identities was there. One is a plus b whole square minus 2ab, and another one a minus b whole square plus 2ab. So from this you can go along this or along this one. Since a plus b is given, so we can write this line. See, this can be written as 2p whole square plus 5q whole square. So a square plus b square. Since a plus b is given, so we will use this one. So this can be written as 2p plus 5q whole square minus 2ab. 2ab means a, b means 5q. Okay. Now put the values. This equals to 16 whole square minus 2 to the 4, 4 5s are 20. That means 20 pq. Now 16 square is what? 296. 296. Okay, 16 square means 256 minus 20 into, put the value of pq is given 6, so 256 minus 120. Now subtract it, then it will be 6, it will be 6, 3, 136. This complete the solution. Understood? Next, we will derive one more new identities, okay, from our previous well-known identities. Just try to remind, we have already discussed that a plus b plus c, the identities for a plus b plus c whole square. What are the identities? A plus b plus c whole square equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. If we take common here 2, then a square plus b square plus c square. If we take common 2 from last 3 terms, then if we take common 2, then the first left will be ab. For second term, 2 I have taken common, so plus bc plus ac. So this is a new form of these identities. Okay, so we need it to solve some problems. Next, we will solve a problem on the basis of these identities. I am writing the question. Actually, we are going to solve problem number 14. Next we will solve a problem by using this identities. Okay. Next we will solve problem number 14. 14 number problem. 14 number problem is given that if a plus b plus c equals to eight, and AB plus BC plus C equals to 19, AB plus BC. This is the problem, that if A square plus B square plus C square minus AB minus BC minus AC equals to 0, then we have to prove A equals to B equals to C. Okay, I'll prove it, but you have to watch this part very carefully and with your full attention. Okay, this is very easy problem. Otherwise you will not understand the proof. Okay, so I am solving. Okay, given a square plus b square plus c square minus ab minus bc minus ac equals to 0. Okay, we multiplying both sides by 2. Okay, multiplying both sides by 2, then left hand side will be 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ab. If you multiply 0 into 2, then it's 0 itself. Okay, now break this 2a square into a square plus a square. Okay, a square plus a square means 2a square. So I am writing a square plus a square in the place of 2a square. Similarly, in the place of 2b square, you have to write b square plus b square. In the place of 2c square, again we are considering c square plus c square. Now keep unchanged all the rest terms. So 2ab minus 2bc minus 2ac equals to 0. Now we have to make the group. Since 2ab is there, so to make a perfect square, we need a square plus b square. Okay, and a square plus b square, and together with minus 2ab we can make a perfect square. So I am making the group. Suppose I am considering this a square, this 1b square, and this minus 2ab. Okay, then a square minus 2ab plus b square. We have taken from the previous line these three terms, which I have marked by red color. Next, we will make the group for 2bc. For 2bc we need b square plus c square. So I am considering this 1b square and this c square, 1c square, and with 2bc. Next I am making the group with the black colors. Then it will be plus b square minus 2bc plus c square. Okay, and for 2ac we will consider the rest terms. Rest terms are a square, here c square, and this 2ac. So plus a square minus 2ac plus c square. Understood? Actually this previous line and this line are basically same, just we have arranged here so that we get the advantage, or we can make the perfect square. Next, by first three terms, by first these three, we can make a minus b whole square. By second triplet, we can make b minus c whole square. See, b minus c whole square, identities for. And for third one, minus 2ac plus c square equal, sorry. For third, we will get a minus c square equals to 0. Okay. Next, we have to make the conclusion. Up to this understood? Now see this line. Here sum of squares. Sum of some squares. Since a minus b whole square is there, so it can't be negative. Since if we consider square of any number, then it must be positive. Suppose 3 square means 9, positive. If we consider minus 5, then whole square, minus 5 whole square means 25 itself. So whole square is there, so it does not depend on a minus b. Whatever a minus b, positive or negative, it will give a positive number. So this is positive, this is positive, this is positive. So sum of positive number will be 0 only when they are individually 0. Okay, that means from this line we conclude that they are individually 0. Okay, so I am erasing this part and writing here. After this line, that since sum of squares is 0, then we conclude that they are individually 0. That means a minus b whole square 0, comma b minus c whole square 0, comma a minus c whole square also 0. So if we solve it, then a minus b whole square 0 means a minus b equals to 0, implies that a equals to b. This is the first part. And b minus c whole square 0 means b minus c equals to 0. That means b equals to c. This is second part. And a minus c equals to 0 for this one, and a equals to c. So now observe properly this result. The first result says that a must be equals to b, and second result says b equals to c. So by chain we can say that a equals to b equals to c. So this completes the proof. Understood? This is very important result. So this completes the chapter also. Okay. Thank you. In my next video, I will start a new chapter. So take care.